Welcome back, guys. Today we'll be doing part 2, implicit differentiation. Let's get started. Now, we are going to differentiate this with respect to x. Now, when we're differentiating 2x, differentiating the x variable, it will become 1. So 2 times 1, that would give us 2. So in other words, when I differentiate 2x, I will get 2. The x become 1. If you're wondering why is it that the x become 1, remember x is raised to the power 1. So differentiating this, we carry the 1 in front. So we'll have 1x. Then subtract 1 from the power. So 1 minus 1 is 0. And we know anything raised to the power 0 is 1. So always remember, when you differentiate the variable x, it will become 1. So in other words, differentiating 2x, it will become 2 where the x disappears. Now differentiating y cubed, when you see a y, just remember you need to put dy dx. So in other words, differentiating y cubed, it will become minus 3y squared dy dx. So remember, it's like chain rule. So we differentiate the outside. So we have y cubed. So we carry the 3 in front. So that's why I have a 3 right here. And then I subtract 1 from the power. So we get a 2 here. And then we differentiate the y. It's going to be dy dx. Remember the previous video I was explaining that it's just like when you're doing chain rule, you differentiate the outside, then you differentiate the inside. So y represents a function. So whatever function that is, you'd have differentiated that function. That's why we have dy dx. But the easier way to remember this, when we're differentiating implicitly, we are going to differentiate the y variable. So we carry the 3 in front, subtract 1 from the power to get 2, and then we write dy dx. Now over this side, we have two functions. So it means I am going to apply product rule. So we're going to have minus and then in bracket. If you forget what's product rule, let me just put it right here. You have uv is equal to uv prime, and remember order doesn't matter, plus vu prime. And others would have written it as u prime then v plus v prime then u. That's fine. Now I'm differentiating. Now what I did, if you realize I left the minus sign on the outside. So I am just going to differentiate 5x squared y cubed. You could have left the 5 outside, but I'm differentiating it. So I have 5x squared y cubed. So I'm going to differentiate 5x squared. So differentiating 5x squared. So what I'm going to do, I am going to let u be 5x squared. So I let my u be 5x squared. And then my v to be y cubed. So what is my u prime? U prime, I am going to differentiate 5x squared. So 5 times 2, that's 10. Then we subtract 1 from the power, so it's just 10x. While for the y cube, I am going to have, so remember this is the derivative. So v prime, because it's a y variable, we differentiate the y variable. So I'm going to carry the 3 in front, subtract 1 from the power, and then I'm going to have a dy dx. That's the easy way to remember this. Rather than saying, okay, I need to differentiate the outside, which is what we're doing. We carry the 3 in front, then we subtract 1, and then we differentiate the inside where y represents a function. So that's why when we differentiate it, we'll have dy dx. So the easier way is just to say differentiate y cubed. We have 3y squared because we carry the 3 in front, subtract 1 from the power, and then we attach dy dx. So applying product rule, I am going to substitute it here. What is u? U is 5x squared. So let me go ahead, write my 5x squared. So I'll have 5x squared here. And then Replace what is v prime. V prime is 3y squared dy dx. So I will have 3y squared dy dx. Then I'm going to have plus. Then what is my v? V is y cubed. So I'm going to go ahead and write my y cubed. And then what is u prime? U prime is 10x. So I'll have my 10x here. So differentiating this, you have to use product rule. So if it was a fraction, then we would have to use quotient rule. Substituting into the format that I have here, u is 5x squared, v prime is 3y squared dy dx, plus my v is y cubed and my u prime is 10x, is equal to, differentiating 5, it's a constant, it's neither an x variable or a y, so therefore it will be 0. Differentiating minus y, that will be minus, no, remember when I was differentiating x, I said differentiating x will become a 1. It's the same concept here. You differentiate y, it becomes a 1, but because it's a y function, we attach dy dx. Once you're comfortable, you just write minus dy dx. But for now, just remember, we differentiate the y, it becomes 1. Just like how I differentiated the x, it becomes 1. Differentiate y, it becomes 1. If somebody wondering, how is it that it becomes a 1? Remember, y is raised to the power 1. So applying the rule, we carry the 1 in front. So I'll have 1y, subtract 1 from the power. So I'll have 0. Then we differentiate the y, so we get dy over dx. And remember, anything raised to the power 0 is 1. So therefore, we'll have 1 dy dx. But the easier method, just remember, differentiate y, you get 1. And then attach dy dx. And the minus sign, we have to continue with this. So our next step is to distribute this sign. This will change to a negative. This will change to a negative. And also, I'm going to multiply these two numbers. So let me go ahead and rewrite. So I have 2 minus 3y squared dy over dx. 5 times 3 is 15. So I'll have 15x squared y squared dy dx. And then this changes it to minus. So I have minus 15x squared y squared dy over dx. Then we multiply minus times positive. So the negative times positive, because the subtraction sign is like a negative sign. So the negative times positive, so that changes to negative. So I have minus. I will be rearranging this. So I'm going to have 10xy cubed. You don't have to, but that's my decision to rearrange. Is equal to, now this part, I can just rewrite it as minus dy over dx. Now my next line, I am going to carry the minus dy over dx over the equal sign, so it will be positive, while the 2 and the minus 10x y cubed will be going over the other side. So let me go ahead and I'm going to write 1, 2 first. So minus 3y squared dy dx, I'm going to write that first. So minus 3y squared dy over dx. And then I write minus 15x squared y squared dy over dx. Plus, because I'm carrying this over the equal sign, so it will be plus dy over dx. Is equal to, the 2 will become minus 2, and the minus 10xy cubed will become positive 10xy cubed. Now, on my left-hand side, I am going to factor out the dy over dx. So I factor out dy over dx, and what am I left with? I'm left with minus 3y squared minus 15x squared y squared. Now right here, don't leave it empty. It's 1. You put 1 as a placeholder because remember when we expand, we should be getting above. So dy over dx times minus 3y squared, I'll get the above. And dy over dx times what we have here, we're getting the above. And dy over dx times 1, where 1 is a placeholder, I will get dy over dx. So if there was a number 2, then I will have 2 in this position. But remember, this will be a 1 in this position when we factor out the dy dx is equal to what I already have on my right. So minus 2 plus 10xy cubed. Finally, I'm going to divide both sides by minus 3y squared minus 15x squared y squared plus 1. So divide both sides by this information, y squared minus 15x squared y squared plus 1. This cancels. So what am I left with? I'm left with dy over dx is equal to minus 2 plus 10xy cubed minus 3y squared minus 15x squared y squared plus 1. And that's it. This is the derivative. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And guess what? Part 3 next week.